that we've actually brought to market AMD's first Fusion APU, Accelerated Processing Unit, and the APU has got a 2 x86 cores that feature the Bobcat x86. Married with that, we have a discrete graphics level of GPU capability, and it also has an integrated universal video decoder. Right, this is available on HP's website right now. It's a DM1Z machine featuring the A350, which is a dual-core 18-watt TDP part. What we're running here simultaneously is calculating pi to 32 million decimal points on both processors. We're running an n-body simulation on the graphics core, running that sort of currently it's running at sort of 12 gigaflops, and we have a playback here, an H.264 playback on the universal video decoder. So married all this stuff together, and we plugged this out last night. We actually ran this demo for 4 hours. This is absolutely soaking the processor, 18 watts or close to 18 watts, and we still had a 4-hour plus battery life on this. So if we actually translated that into real world use, that translates to I think a 10-hour battery life for this actual product here.
And we demonstrate that with these demonstrator over here. So that is actually a see-through optics. So maybe you can see the display in your camera, and the display that actually provides the display image is over here. And this device also contains an image sensor at the same time. And the idea is that one can use these IPs and get a virtual image from the display, from the OLED micro display, and by the embedded image sensor, or at the same time the eye is being detected, the eye movement is being detected, and by that yes, we should have a chance to see the eye over here. And the basic idea is to have virtual buttons in this virtual images.
We actually believe that flash is not the ideal memory that we can use for microcontroller. That's why we have looked at the FERAM. FERAM is really native, working from 1.5 volts. It's not requiring 10 or 12 like on a flash where you have a charge pump. And then finally, actually, the endurance is quite different. On a flash, you're usually limited to 10K samples. In our case, we actually have over 100 trillion write and erase cycles on that one. Doing like an apples-to-apples comparison, and we're now writing with 12 kilobytes to both devices at the same time. On the flash, there's no difference. This is exactly what we have seen before, 2.3 milliamps. However, on the FERAM device, we have currently only about 10 microamps, and this is really because it mainly sits in low power mode, waits for the next byte to come in, writes it back, and goes back into low power mode.
This form uses an inexpensive LCCL balun to replace the SAW filters in front of the LNA for the lowest cost implementation. The first demonstrations will show the sensitivity and out-of-band blocker measurement. There are two key performances will be measured using this setup. The first one is the baseline sensitivity, which can be simplified, measured by this tester. The second one is the out-of-band blocking margin. According to the toughest case defined in the ETSI specification, the measurement results shows that the average sensitivity is around minus 111 dBm in low band and high band, which is better than the SAW-based conventional receiver. The second demonstration is intended to show the phone call quality of the Solis receiver is not influenced by the blocker from the BT signal. The phone call quality of the Solis receiver is the same with or without the BT blocker, as indicated by the music playing by this receiver receiving end.
This is the world first HGSM quad-band CMOS power amplifier. CMOS linear power amplifier have several drawbacks compared with compound semiconductor devices. To overcome the disadvantages, we use the novel adaptive bias circuit technique and linearized CDG to improve the AM/AM and AM/PM distortion. For efficient impedance matching and power combining, we use the output transformers based on the high Q IPD technology. The power amplifier amplified the modulated signals. Those signals are displayed on the signal analyzer and laptop computers.
In this work, we propose to use half-UI post-cursor FIR plus IR tap filtering method instead of a 3-tap canonical transmitter architecture to satisfy optimize both specs at the same time. Then I condition the data by using half-UI post-cursor FIR plus IR tap filtering method. We hope to improve the data-dependent jitter and the TWDP at the same time. As we can see, at the middle of the eye, AC swing is higher than the DC swing. It means we lowered the TWDP with this setting. And then when we look at the jitter value, it's around 5.5 picosecond. It means we almost cut the DDJ by half by using a half-UI FIR plus IR tap filtering method.
I'm actually wearing now an ECG necklace which is connected to my chest with electrodes. The electrodes pick up the electrical signal produced by my heart and then it's amplified and collected and transmitted by our radio to the PC.
As my colleague says, the pen radio is very ultra low power, so the power consumption is below 1 milliwatt for a distance of 2 to 3 meters. So it's one of the lowest power consumption on the market radio.